In this video, we're going to be reviewing higher order derivatives. So this is the position function, and it is 3x cubed plus 4x squared minus 5x. And we're going to just be finding the first, second, and third derivatives of this. So the first will be 9x squared plus 8x minus 5. The second derivative will be 18x plus 8. And the last derivative will be 18. Our next problem is a word problem, and it states the soccer team's goalkeeper punts the ball upward with an initial velocity of 40 feet per second, and the ball was kicked from a height of 3 feet. Question A is find the position, velocity, and acceleration functions of the ball's movement. And question B is find the height and velocity of the ball at t equals 1 and t equals 2 seconds. So we know that the ball was kicked with an initial velocity of 40 feet per second. So that would be initial velocity equals 40 feet per second. And it was kicked from a height of 3 feet. H equals 3. So to find the position, velocity, and acceleration functions of the ball's movement, we're going to have to start with the position function. S of t equals negative 16t squared plus, we plug in the 40 feet per second for the velocity, 40t plus 3, which is the height the ball was kicked from. And to find the velocity function, we're going to take the derivative of s of t. So it'd be s prime of t, also known as v of t, equals negative 32t plus 40. And to find the acceleration function, we're just going to have to take the derivative of v of t. So it'd be s double prime of t equals v prime of t equals a of t, and that equals negative 32. So the ball had an acceleration of negative 32 feet per second per second. For question 2b, we're going to be plugging in into the position and the velocity function. So we're going to be plugging into s of t, which is negative 16t squared plus 40t plus 3, and the velocity, which is t, or negative 32t plus 40. And we're going to be plugging in t equals 1 and t equals 2 into these functions. For s of 1, we get 27. For s of 2, we get 19. So at 1 second, the ball was 27 feet up, and at 2 seconds, the ball was 19 feet up. And for the velocity function, we plug in 1, we get 8 feet per second. And when we plug in 2, we get negative 24 feet per second. So when the ball is at 1 second in its flight, it's going at 8 feet per second. And when it's 2 seconds into its flight, it's going negative 24 feet per second because it's going down. A skateboarder traveling at a rate of 25 feet per second starts to drag his foot on the concrete to brake. The position function for the skater is s of t equals negative 5.5t squared plus 25t, where s is measured in feet and t is measured in seconds. Use the function to complete the table. For number 3, we're going to be completing this chart right here, and we have the time in seconds from 0 to 3, and we have our position functions to our acceleration function. So we're going to start by just plugging in every value into their respective function. So plugging in 0 into s of t, we're going to get negative 5.5 times 0 squared plus 25 times 0. That'd just be 0. And we're just going to go on from there. So when we plug in 1, 19.5. When we plug in 2, we get 28. 3, 25.5. Plugging into the next function, which is the velocity, we get 25, 14, 3, and negative 8. And when we plug in something to the acceleration function, nothing's going to happen because it's just negative 11. So we're just going to put negative 11 for the acceleration. And that's your table completed.